chemistry candidates. Welcome. Yeah. So welcome to Aspiration International School. All right. My name is Mr. Un. All right. So what we're going to be today, what we are going to do today is I've selected what you see on the screen. They are your topics, okay, in your syllabus, and I've selected under each topic just a few questions, all right, that will maybe evoke some questions and will be good starting points for us to do brief revisions on the particular topic. Yeah. So and remember to hit the subscribe button, all right, so that you know what's happening with our school. And if you have any questions, please remember to put them in the chat. All right. Okay, I'm going to start. Okay, so this is the first question, yeah? Can you take a moment to read through? And if you like, you can put your answer in the chat. Now, this question looks simple, but you know, it can be quite tricky, yeah? It can be quite tricky. So immediately we try to eliminate the obvious and wrong answer. Okay. So the question is, which gas is both monatomic? All right. So let's deal with monatomic. So you know that monatomic gases are usually in group A. They are the noble gases. All right. So immediately we know that nitrogen is definitely not monatomic. In fact, nitrogen is known as, okay, diatomic gases. So immediately D is out. So now you've got three monatomic gases to choose from, and they want a liquid at negative 200. So let me know what's your answer. Oh, hi guys. Correct. The answer is A. Hello everybody. Yes, the answer is A. Now, it'll be easy if I do it graphically. So let's say at 0 degrees Celsius, all right, then you have negative 200 here. Now let's look at argon. They said that the boiling point is negative 186. Now look at this. So when you look at it visually, it's different, right? Okay. This is the boiling point of argon. So at negative 200, has argon boiled? No, argon has not boiled. So therefore, the argon remains as a liquid. Now let's take for example helium and neon. Okay, so neon is negative 246 over here, all right, and helium is negative 269. Now at this point, okay, in time, the temperature is negative 200. It is above the boiling point. So therefore, helium and neon exist as gases at negative 200. So the answer is A. Now moving on. Any questions? Okay, I hope that is clear. Huh? Okay. If you have any questions, just put them in the chat. Okay, moving on. Now, have a read through, and if you have questions, do ask or key in your answer. I don't think I'll be able to go through all questions today. If not, it'll be too long. So you can see over there, part 2 is on Monday, 3 p.m. Yeah, 16th of November. So I hope that I'll see you there again. Yeah? So what's the answer for this question? Can I see some answers for this question? B and D. Okay, now it's a very simple question, but many students are confused. Yeah. Okay. Okay. Yeah. So it says that if the ice. So one thing you need to understand, right? So if the ice is melting, that means temperature does not change. Okay. So if the ice is melting, temperature does not change. So immediately you know that A and B is wrong. So it's either C or D. Now, and when the temperature does not change, the kinetic energy does the average kinetic energy does not change too. So C is wrong. So the answer for this question is D. So take this home, yeah. All right. Hello, Angsin. I see your answer. Okay, thank you for participating. Yeah, all of you. So yeah, remember, so when the ice is melting, temperature doesn't change, and when temperature doesn't change, kinetic energy does not change. All right, next question. Come quickly key in your answers. Kenjin, you're the first one and you're absolutely right. Okay, so remember, for rate of reaction, okay, you need a physical quantity, a physical quantity over time. So you definitely need a clock. Okay, so change in mass, the physical quantity is the change in mass, so you need a balance to measure that. And in the second reaction, you need a thermometer. Okay, so physical quantity over time. So in both, you need the clock. So the answer is B. Very good. Okay, if you have any questions whatsoever, remember to insert it in the chat. Moving on. Paper chromatography. We all know about paper chromatography, don't we? Yeah. So what do you think is the answer for this one? So remember to eliminate the wrong answers, okay? Always do that. Okay, Miyoko says A. Kenjin says A. Alright, let's have a look. Yeah. Number 1. One of the substances in the mixture is insoluble. That's wrong. Okay, so immediately A and B is wrong. Do you see that by doing this, you really increase your chance of getting this question correct? Now, if the if one of the substances is not soluble, then please remember, so now this is what you have. Now if one of the substance is not soluble, it will be here. Okay, let's read number 2. The locating agent did not react with one of the substances. This is plausible. So if the locating agent did not react, then you will not see the spot. So 2 is not bad. Now if you are very, very certain that 2 is the answer, then the answer will be C already, right? Okay, so at this point you're almost sure it's C. Let's read on number 3. 2 of the substances in the mixture have the same RF values. Absolutely plausible. Alright, so in one spot you could have 2 mixtures, they both have the same RF value. So 3 is correct. Let's look at number 4. The RF value of one of the substances is too small. Now if the RF value of one of the substances is too small, then they will be very similar to number 4. Very similar. Alright, that means you are going to look at a spot here, which is not the case. The baseline is empty, which is why number 4 is also wrong. So therefore C is the answer. Any questions? So remember that if the RF value is too small, or if the substance is insoluble, you will get the dot on the baseline. Okay, good so far. Moving on. Are you done? Okay, key in your answers now. It's okay, don't be shy. You can just, key your answers in. Alright. Jia Ian A. Okay, I've seen your answers. Okay. It's not ionic, so it's wrong. Oopsie. Ammonia is not ionic. Nitrogen atom has a noble gas configuration, but hydrogen atoms do not. It's pretty weird, because if you have noble gas configuration, what are you doing here in a reaction, right? So no. Okay, C. Nitrogen, so C and D is pretty close. So what do we need to do? Alright, we need to draw it out. Okay, so nitrogen is in group 5. Okay, so you have so if you have 5 electrons on the outer shell, you need to share 3. So this 3 is all ready for sharing, while this 2 is a non-bonding pair. Then you will have hydrogen, and hydrogen. So immediately you know that C is wrong because it is not being shared, right? So the answer is D. Okay, any questions so far? So sometimes, to be sure, especially during the exam when your confidence level is pretty low, alright, you find yourself using the calculator for ridiculous, questions, right? Yeah, draw it out. Okay, draw it out to be sure. Okay, if you have any questions, please keep them coming. What about this? So this really brings us down to the foundation, okay? To the foundation of chemistry. And I'm interested to see your answers. So for those of you who attended the physics lesson yesterday, I hope that you can see the difference for today. I have reduced the latency to almost zero, as low as I can get, so it is pretty, the lag is very, very small. So can I see some answers, please? D, A. The answer is A. Well done. Now, because you need to understand, alright, covalent bonds, okay, covalent bonds are formed between atoms of non-metal and non-metal. So non-metal and non-metal atoms react, share electrons, and they form covalent bonds. So in this question, you are trying to get rid of the metal, right? We are trying to get rid of the metal. So metals, right, they have valence electrons, all right, of 1, 2, or 3, right? So automatically we know that A is a metal. So A does not form covalent bonds because covalent bonds are formed between atoms of non-metals. B, the valence electron is 4, so it's a non-metal. C is 7, alright, so it's a non-metal. And D is 6, so it is a non-metal. So B, C, D, they are non-metals and they can form covalent bonds by sharing electrons. Okay? Moving on. Now, when they ask you, when they are asking for chemical properties, you need to know that chemical properties depend mainly on the valence electrons. Okay, and if you've got more choices, like you have given the protons and the neutrons, then it's of course very good to also get the same proton number. All right, so the electrons must be the same. That's the first thing you are looking at. Yeah, most of you are right. It's B. Yeah, it's B. So automatically A is wrong. Okay, and automatically, yeah, A is wrong. All right. So of course you should go with B because even the proton number is the same as the number of electrons. So it's very clearly B. I'm very happy. All right, everyone did very well for this question. Good job. Good job. So remember, chemical properties depend on the number of valence electrons, and of course, if the number of protons are the same, all the better. All the better. Moving on. There we go. Stoichiometry. All right. Everyone hates that topic, right? No, it's very interesting. It's the mathematical part of chemistry. I want to see your answers. This is as difficult as it gets for stoichiometry in chemistry. So show me. Miyoko says it's C. Okay, very good. Many of you all said the answer is A. Well, that's good. Let's see. Okay, so look at hydrogen and ammonia. So the ratio is 3 to 2. So when they tell you that the moles of hydrogen is 0.75, I hope you didn't go into some major calculation to get the moles, right? Yeah, so this is like 0.5. So this is the first step. Alright. Then the volume is moles times 24. So you get you will get 0.5 times 24. So you're going to get 12 decimeter cube, which will be 12,000 centimeter cube. Alright, and of course you got to take 30% off of that because they say that the yield is only 30%. So from 12,000 you will get 3,600. Well done, huh? Miyoko, Angsin and Dion. Moving on. Okay, so that's stoichiometry. Now we are going to electrochemistry. What do you think is wrong with this setup? Can I see some answers? What do you think is wrong with this setup? D. Absolutely right. The answer for number 5 is D. Okay, very good. Okay, so you remember, okay, object to be plated, okay, at the cathode. But in this case, in this question, the object to be plated, which is the metal ring, is at the anode. So you've got to switch the connections round. Yeah, the metal ring should be at the shorter end of the cell, the battery, the 2 cells there, right? So switch the connections. Well done. Any questions? Remember, you can just key them in. Yeah. Moving on. All right. What do you think about this question? CAA. Alright. So we have A, B, C and D. Let's look at the electrons. I hope you know that electrons is either 3 or 4. Okay? I hope you know that electrons is either 3 or 4. Now electrons are donated at the anode and they move up. So it's 3. Okay? So electrons is 3, yeah? The direction goes up from the anode. So immediately you know that B and D is wrong. Okay? So it's either A and C now. Now copper ions is Cu2 plus, yeah? Cu2 plus is of course attracted to the negative. So it's 2, so the answer is C. Well done to those of you who guessed correctly. Alright, yeah. So copper ions are attracted to the negative, so they are going according to number 2. Alright, so the answer is C. Any questions? Moving on. Okay. So that's for electrochemistry. Now we are moving on to chemical energetic. So this one is the endothermic and exothermic reactions and their calculations. Okay. What do you think, guys? What would you say is the answer? Wow. Hi, Rohan. Yep, you are right. It is C. So, please note that substances, alright, that need some heat to get started with the reaction. Okay, sorry. Reactants that need heat for them to continue their reaction, they constantly need heat. It is a sign of endothermic reaction, because endothermic reaction is absorbing heat energy. So for C, you need to give it heat, if not, nothing's going to happen. So even as you recognize that C is endothermic, right, please note, alright, for A, B and D, okay, those are exothermic reactions. Okay, of course combustion for B is exothermic, definitely, and neutralizations are always exothermic. So learn to recognize exothermic reactions as well. Moving on. Alright, looks like a very tough question. Guys, what do you think this is? Is this an exothermic or an endothermic reaction? Can you put your answer in the chat? Is this exo or endo? Do you think this is exo or endothermic reaction? You're right, guys. This is exothermic reaction. So exothermic is positive or negative? Exothermic, since we have established that it is exothermic, is exothermic positive or negative? Yeah, negative. So now you're down to A and B, right? Since you know that exothermic is negative, well, the answer is just, yeah, you look at the graph. Yeah, energy change is just this bit. So you got to find the difference. So you take the difference, yeah, you got to take 250 minus 342, the answer is B. So that's how, with some theoretical knowledge, you just increase your chance of getting it right. So you know it's exothermic, so you choose the negative answer. Your chance of getting it right is 50%, right? Once you have deleted the two answers. Huh? Moving on. This needs some calculations. So do your calculations and let's see who's the first one to get the answer. Now what I would do, alright, is to draw them out. Okay, so for bond breaking, you should draw it out. So bond breaking would be the reactants. It looks like all the bonds are broken and all the bonds are formed because there's very little between the two of them. Huh? Oxygen. So if you remember to draw them out, it will really help. Yeah. So for bond breaking, what are we looking at? Yeah, we are looking at 614. And we have 4 CHs, which is 413. Is anyone getting the answer already? And 495 times 3. So I've got a positive 3751. Now you can see the size of my positive sign. Alright, is proportional to the importance of having it there. Alright, especially in this topic. Now let's look at the bond forming. Alright, when we look at the bond forming, we have a carbon dioxide, we've got 2 carbon dioxides, and water, 2 moles of water. So now that is what they look like. That should aid you in your calculations. So you have 799. So this is your bond forming. Alright, so it's 799 times 4. And O and the H, you've got 467 times 4. Wow, I see all the answers coming in. Alright. So I've got negative 5064. So energy change is BB plus BF, right? So it's equals to 3751, sorry, 1 minus 5064. And the answer is 1313, I think. Huh? Correct. So the answer is C. Okay, so I hope those who are not clear, you are clear now. Just remember, bond forming happens with the reactants and bond forming happens with the products. Bond forming is positive, bond breaking is positive, sorry, bond forming is negative, and then this is the formula. So you should be well acquainted with that. Moving on. Any questions, please put them in the chat. Alright, so now we are going to the next topic, which are chemical reactions. So under this topic, you have your redox, you have your reversible, and you have your rate of reaction. Okay? So come on. What do you think the answer is to this question? B, says Kenjin. Anyone supports him? Oh, wow. Whoa, whoa, whoa. All the B's are coming. Okay. Well, the forward is endo. Alright. So whenever the forward is endo, you have the word heat here and you have the word cool over here. So definitely higher temperature will move the equilibrium to the right. So the answer is either B or D. Alright. Okay. Now for pressure, you need to look at the moles. So firstly, you need to check whether they are all gases. Methane is a gas, water is steam, alright, it's a gas. Carbon monoxide is a gas, hydrogen is a gas. So they are all gases, alright. So you have 2 moles versus 4. So now if you want to move the equilibrium to the right, you need to find a pressure condition that will favor the one with the higher moles. So if I were you, I would go with decreasing the pressure, because decreasing the pressure favors the right side with more moles of gas. Wonderful to all of you who tried. Thank you for participating. Yeah, thank you. Well done. Well done. Moving on. All right. Try this out. What do you think the answer is for this one? Wow. Ian Angsin, very good. Okay. No, Rohan, no. Okay. Rarely thermal decompositions are redox reactions. Thermal decompositions are usually not redox. So the first reaction, nah. Okay, so then you will have to look at the second reaction. So you've got copper oxide plus tin oxide. Now you have copper plus tin oxide. Look at this. You are definitely reduced, right? Because you lost oxygen. So remember, when you lose oxygen, you are reduced. When you gain oxygen, you have gone through oxidation. Huh? So who is oxidized? Definitely it looks like the tin, because you gain oxygen. Okay, so who went through oxidation? So the answer is D. Okay, I hope this is clear. Any questions? Okay, if you have questions, do keep them coming. Moving on. Another redox. Let me know what you think. Yeah. What do you think the answer is for this one? Alright, now can you please tell me what happened here? Is this oxidation? Well, I'm seeing all different alphabets that's happening here. Alright, all different alphabets. Now can you key this in? This first arrow in blank, alright, is this oxidation or reduction? This arrow in black, is it oxidation or reduction? Okay. So, and then this arrow in red, is it oxidation or reduction? Can you help me by typing black oxidation or reduction and then red oxidation or reduction? Can you help me? Okay, so yeah, let me know if the black one is oxidation or reduction and the red one, so you could type black and red. Yeah, red. Alright, okay, good. So this one is oxidation, and I have to agree. Now it is oxidation because of a few things. Yeah, thank you guys. Yes. Okay, incidentally, red, reduction, you know. Anyway, oxidation. Alright, now this is oxidation because zinc, alright, became Zn2 plus, and it does this by giving away 2 electrons. Okay, so zinc is the reducing agent. Alright, now let's look at the reduction. Okay, so copper 2 plus became copper atoms, and it did this by accepting electrons. Okay, so therefore copper sulfate is the oxidizing agent because it has gone through reduction. So now let's answer the question. So now we know who went through oxidation, who went through reduction. We know who is the oxidizing agent and who is the reducing agent. Okay, so the oxidation state of the oxidizing agent has changed from 0 to 2. So the oxidizing agent is copper. Does this look like 0 to 2 to you? No, right? So therefore, automatically we know that A is wrong. Okay? I see everyone has put almost every alphabet out there, so this is quite confusing. Now, the second one, B. The reducing agent has changed from 0 to 2 plus. It looks good. Looks good. Yeah. Because C is totally contradictory to B, so B should be the answer. Now, this is not a redox. Of course, this is absolutely ridiculous, right? Okay. If anything, the solution changed from blue to colorless solution. So D is 100% wrong. Huh? So the answer is B. Any questions? Can I see them in the chat? I hope this is clear. Is there anything that's not clear? Guys, I'm looking at the chat all the time, yeah, so just put whatever you need in the chat and I'll get back to you. Huh? Alright. I think the solution to this question is pretty simple. However, I feel that there is something to be learned in this question. Let's see your answers. Wow, Jiaxuan. Wow. Is it so simple? Okay. Yes, the answer is A. Okay. Very good. Okay. Now, but I want you to write down in the chat. Okay. Why not C? Can you write down the answer? Why not C? Okay. Alright, I didn't expect that. Yes. Ang Sin, I like your answer. Very good. Now, okay, assuming that, okay, let's assume, alright, let's assume that surface area is the same. If we assume that surface area is the same, can we use more zinc? The answer is no, because the volume of hydrogen is the same for X and Y, because the sulfuric acid is the excess reactant and the zinc is the limiting. So we cannot manipulate the amount of zinc that we add. Very good. I'm actually very, very happy with all your answers. All very good. Very good. This is where you all will get caught. Let me know what you think. What is the answer? Yes, I'm reading all your answers, yeah? Very good. Now what about the next one? C and B. Well, I think this is quite a confusing question. Yeah, oh, the answers are rolling in. Yeah, Alright, let's have a look. Okay. So firstly, you have barium iodide, okay, reacting with lead nitrate. Okay, so what are you going to get? You're going to get barium nitrate and lead iodide. So this is the yellow precipitate. Well done, well done, well done. So A, B, C, and D. Well, the answer is either C or D, right? Because lead iodide is yellow. Alright. Now this is the filtrate, right? So this is the filtrate. So now this filtrate, alright, which is barium nitrate, alright, it's going to be reacted with sulfuric acid. So this is a precipitation reaction. This is also a precipitation reaction. Remember, you can use sodium, potassium, or hydrogen over here for a precipitation reaction. Okay, so you're going to get barium sulfate. So you all know that lead iodide, you have to memorize that it is insoluble. The same as barium sulfate. Yeah, barium sulfate is a white precipitate, and you're going to get nitric acid. So yes, the answer is C. I hope this is clear. Is there any question you'd like to ask, Rohan? Or anyone who did not get it, please don't be shy, just ask. Yeah, no one knows who you are anyway except me. Yeah, any questions you'll have? Alright, any questions? Can go ahead and ask. Right, now look at this next question. So basically, even for testing of ions, yeah, you need to memorize. Alright, you need to memorize the common precipitates. Okay, and I hope you have an idea by now. Alright, especially silver halides, lead halides, barium sulfate. Alright, these are standard questions that they will ask you. Okay? Yeah. Okay, new answers are rolling in. White precipitate. Okay. Wow, wow, wow. Okay, a lot of memory work going on, yeah? Very good, very good. Okay, A, you're going to get a white precipitate, so white is the answer. Can you tell me the color of B? What will B give you? What color will B give you? A is the answer, guys. Well done. Alright. Can you please key in what color will B be? B is yellow. Very good, Miyoko. Can you tell me C? What color is C? What color is C? Blue precipitate. Very good. Can you now tell me what color is D? What color is D? Absolutely right. So they will all give you precipitates, yeah? So all of these will give you precipitates. So if they're asking for white, the answer is A. Very good. Moving on. Thank you for participating, all of you. Now, let's move on. Very good, very good. So all of you, I hope you know that acid is a proton donor, a base is a proton acceptor. All right. So immediately A and B is out of the question. All right. And a weak acid, of course, is partially ionized. So the answer is D. Thank you for participating. I see we have a new friend, Hu Ting. Yeah, thanks for joining us. Okay, just participate, right? Okay. Can you just, I shouldn't be discussing this question. Can you just quickly hammer in the answer for this, please? A. Are you talking about this question, Rohan? What do you think this is, guys? Okay. Yeah. So it's silver chloride, which is a white precipitate. We have discussed this already. Yeah. So we'll not spend any more time here. We are going to move on. Okay. Okay. Now, where are we now? So we have done topic 1 to 8, right? So we have done topic 1 to 8. All right. So now we are moving on to the periodic table. So we have covered more than half of what we wanted to cover. Alright? And I think you all are doing very well. So let's move on. Titanium. What are the properties of titanium? So of course you know that titanium is a transition metal. So remember, in your test paper at the end you will have the periodic table, and whoever is in the middle, right, is the transition metal. Alright, and yes, you are right, the answer is B. So remember, for transition metals, right, they act as a catalyst. They form colored ions or compounds. Alright, they have variable oxidation states. So what I'm doing, I'm writing down the chemical properties, right? The special chemical properties of transition metals. Yep, the answer is B. Yeah, and the last one will be, it forms complex ions. So these are the chemical properties, and the physical properties are the usual ones. Well, they always draw a distinction between transition metals and group 1. So, of course, all metals conduct electricity, so the second column is definitely a given. So, transition metals, definitely, they have high density, alright, and they are definitely less reactive compared to group 1. So, very good. The answer is B. Well done. So, if you did not know this, alright, or if you've forgotten, this is a good time for you to revise. Alright. Next question. Show me your answers. Wow, that's very quick, Rohan. Yeah. So, yes, in the same period means same row. So very good. And metals are on the left. So metals are on the left, non-metals are on the right. Okay. So yes, the answer is D. Alright. So because we choose the ones on the left and on the same row. Okay. So yeah. Moving on. Okay, this is interesting. Okay, let me see what you answer. Of course, the difficulty is on the products column, yeah? The difficulty is in the products column. What do you think this is? Thank you for participating. So very clear cut, the answer is B. So I hope, well, I'm very surprised actually, very good. So I would have you all know, alright, that for group 1 metals, all the way to calcium, alright, when these react with water, this produces hydroxides. Now usually for those below calcium, if you react, and remember this can react with cold water. When you can react with cold water, it means that you are very reactive. So if you can react with cold water, you are reactive, and more reactive metals, they form hydroxides. Now for the less reactive metals, you need to use warm water or hot water or even steam. So when less reactive metals react with water or steam, you are going to get oxides. So just remember, less reactive metals react with water to form oxides, and more reactive metal reacts with water to form hydroxide. So very little in between them. So you need to know the difference. Okay, so group 1 up to calcium, if you react with water, you're going to get hydroxides. Alright, after that you're going to get an oxide. So the answer is B. Very good, B. Okay, what do you think about this question? So I think it's very important, they want you to really understand the definition of alloys. Okay, so I hope you know the full definition of an alloy. Yep guys, it's B. So an alloy is a mixture. Okay, an alloy is a mixture, not necessarily all metals, but usually the main component is a metal. So remember, alloys are mixtures and the main components are metals. Very good. So solder is an alloy and it is just a mixture. So this is a standard question. Alright, it's really a common IGCSE question, and I chose it because I really want you all to know, alright, the answer to this question. Wow, that's really quick. Yeah, it just so happens that all the answers are B, right? So I do not know where to draw the line. Yeah, but mild steel are used in car bodies and machinery. Alright, stainless steel, chemical plant and cutlery. Now who is missing from this? Alright, who is missing from this? Well, aluminium is missing from this. Alright, so usually aluminium. What is the use of aluminium? Can you please key them in now? What is the use of aluminium? Yes, this answer is B. Car bodies, machinery for mild steel, and for stainless steel is chemical plant and cutlery. So airplane bodies, aircraft. I'm looking for something else here. Yes, of course it's correct. Another use of aluminium. Absolutely right. Absolutely right. Food containers, yeah, and overhead cables, yes. But what I'm asking is, what I'm directing your attention is food containers. So yeah. So in IGCSE, it's very common for them to ask to give you the answers for B, and aluminium is under food containers. Very good. Moving on. Think about this question carefully, guys. What do you think? Mercury, Rohan, mercury exists as a liquid at room temperature. So its melting point cannot be 1455. Huh? Yes, the answer is D. Well done, Puting. Huh? It's D. Can I know why not B? Yeah, Angsin, Huting, D, correct. Yeah. Why not B? Why not B? I won't say you guys are wrong. Yeah, okay, you are right. But I would have you know that copper carbonate is green, yeah? And you know there is very little in between. Yes. Oh, Zhao Han, you're here. Goodness me. Hi. Yeah, it's yes. The answer to this question, why not, is because copper is not silver. Copper is pink or brown or light red brown. Very good, Zhao Han. Very good. Very good. Dion also. Very good. Moving on. And of course, the most important thing about metals in this topic is the extraction of iron. Alright? Hi, Zhao Han, yeah? And the extraction of aluminium. So let's deal with the extraction of iron first, yeah? Well done. Yeah, the answer is A. So remember, so hot oxygen goes in, it reacts with carbon, carbon escapes as carbon dioxide, right? Okay, but what is another, right? What is another function of having oxygen reacting with carbon? Yeah, that's my question. What's the other purpose? Yes, you know. So of course, yeah, very good, because this is a blast furnace. Okay, this is a blast furnace. Who think very, yeah, this is very right as well. I was just about to ask that question. Very good. Yes, all correct. All correct. Very good. Well done. Well done. Well done. So, and of course, so the answer is definitely A or B, and the next column, the calcium oxide is a base, it reacts with acid, and the salt is the slag. Alright, and so that's why the answer is not B. It doesn't react with the slag, right? It produces the slag. So the answer is A. Very good. Yeah, to produce the heat. Yeah, and remember, the more popular reducing agent is carbon monoxide, yeah, instead of carbon. So remember that. But that's not really very crucial in paper 2, yeah? Oh, really, Zhao Han? Okay, I hope you did well there. Okay. Now, the manufacture of aluminium. So, extracting aluminium. We extract aluminium using electrolysis because it's a reactive metal. Okay? And we extract iron using the blast furnace, using carbon monoxide because it is less reactive. Yeah, I hope you know that. So what do you think of this question? Okay, A is absolutely wrong. Yeah? Huh? You all are making me doubt myself. How can you be oxidized and you gain electrons, right? Because oxidation is lose electrons. Right? So A is absolutely 100% wrong. Okay? Yeah. So the answer is C. Now it helps to dissolve the aluminium oxide because it reduces the melting point of aluminium oxide. So definitely this will help the aluminium oxide to dissolve. Okay. No, the answer is not B, Rohan, Dion. No. Oxidation is lost, so it's not A. So the answer is C, guys. C, guys. The answer is C, right? The answer is C. Now, what is the ore of aluminium? How do you make B correct? How do you make B correct? Can you please write down the ore of aluminium in the chat, please? What is the ore of aluminium? Bauxite. So B is wrong. Okay, and remember, guys, the negative electrode and the positive electrode. All right. Yes, bauxite. So remember, opposites attract. So aluminium 3 plus goes to the negative. All right, and O2 minus goes to the positive. So Al3 plus goes to the negative, and the O2 minus goes to the positive. So that's why the answer is C. Well, we were all over the place for this one. Okay. I hope this is clear. If you have any questions, please key them in the chat. Okay, and so far you all have been so participative. I'm so glad, right? Thank you so much. All right. So now we have 4 more topics to go. All right. I think we will finish by 4:30. All right. Moving on. Haha. This is a difficult one. I'm gonna catch you here. What do you think is the answer? Ian and Huting, no. Oh. Yeah. The answer is D. Okay. All right. Let's see. So for those of you who chose D, okay, where do oxides of Ian? It's not A, Ian. Carbon monoxide is formed by the incomplete combustion of fuels, right? No. So where do oxides of nitrogen come from? I want to see your answers in the chat, please. Where do oxides of nitrogen come from? The factory chimneys? No, Miyoko, no. Alright. Okay, so we have, the answer is D. D for donkey, So we have established that nitrogen oxides do not come from fuel. So where do they come from? Absolutely correct. Kenjin, Angsin, Rohan, Zhaohan, Huting, very good. Yeah. So in the car engine, when the temperature is high, the oxygen and the nitrogen that is already present in the air that is just so happen to be in the engine, when it's hot, the oxygen reacts with the nitrogen to produce the pollutant known as oxides of nitrogen, which is acidic and can cause acid rains and respiratory complications. Moving on. Wow, this is quick. Yeah. Yes. All right. So, okay, so for hydrogen and nitrogen, so remember for nitrogen we use the fractional distillation of liquid air. So yeah, nitrogen comes from the air and hydrogen comes from reacting natural gas. Okay, yeah, the answer is C, guys. Okay, and it comes from reacting methane. I hope you know that methane is the main component of natural gas. Yeah, so methane plus steam. Okay, so this will produce your hydrogen and your carbon dioxide. Yeah, so I hope you know this. So hydrogen, to get hydrogen, you react methane with steam. All right, and nitrogen from the fractional distillation of liquid air. Well done, guys. The answer is indeed C. Okay, well, okay, I wanted to draw a line because, yeah, okay. Correct. So everyone knows that chlorine is used to kill the bacteria, the germs. Okay? Yeah, correct. So where do you put it in? When you see the word antibacterial, right? So the answer is C. I knew you all would get this right. It's just that, because the water treatment topic gets very little limelight. All right, so when I saw this question, I thought, why not just put it in? All right. Not too difficult though, not too difficult. Yeah. So I'm just putting the word next, yeah, so that it separates the previous question, yeah. Yeah, so on a larger scale, this is a process. What is the name of this process? Galvanizing. Very good, very good, very good. Wow. This group of students, very good, very good, very good, correct. Galvanization, galvanizing, huh? Galvanization sounds weird. All right. Scarification. Okay, what about this question? So now guys, B. Okay, I need you to understand one thing. Yeah, when they say car exhaust and power stations, is basically almost every pollutant out there. Okay, it's almost every pollutant out there. Okay. Okay. Okay, yeah, so it's almost every pollutant out there. All right, so it's almost every pollutant out there. So you just need to ask yourself, sorry, are you distracted? Yeah. So yeah. Okay, so X is combines with only one oxygen, so you've got to ask yourself, yeah. So XO. So can you have CO and can you have NO, right? Well, the answer is yes. Okay. Now, can you have so for YO2? So the question is, can you have NO2, right? Can you have NO2? Yes. All right. Now, can you have SO2? Yes. Can you have CO2? And I'm sure your answer is all yes, yes, yes. All right. So the answer is D. Haha. An interesting question, I think. Moving on. All right. Now, you know the contact process, yeah, is made up of four equations, and they are all there. But one of them is reversible. All right. Yeah, and one of them is reversible. So the reversible reactions require require suitable conditions, right? I'm very distracted. Yeah. So very good, very good. So the answer is B. Correct. So B is the reversible reaction here. So B is the reversible reaction. So yes, you need vanadium oxide as the catalyst. Can you please key in the chat another two more suitable conditions, all right, that would bring this equation to a very optimum level? Can you please key in the other two? 450 degrees Celsius, okay. All right, 450 degrees Celsius. And what about the pressure? Absolutely right. Okay, about 1 to 5 atm. Very good. Goodness me. You all should take the exam right now and you all are going to nail it, right? This question will catch you. Be careful. So what do you think this is? Okay, yeah, the answer is A. Yeah. All right, can you all help me? Yeah, the answer is A. Can you please change? Can you for yeah? Thank you, Zhao Han. So yeah, so for D it's concentrated, right? Now for B and C, can you please key in the correct word to make B and C correct? Just like how Zhao Han wrote for D, can you please key in for B and C to make the sentence correct? Yes, the answer is A. Thank you. C, strong acid. And what about B? Can you make B correct? B is chlorine. Oh, okay. Alright. Okay, but okay, yes, B is chlorine, very good. But did you know that sulfur dioxide is also used as it is also used to kill bacteria, but where? In what situation is sulfur dioxide used to kill bacteria? Yes, sulfur dioxide is used to bleach wood pulp and to act as a... Yes, I know it's to bleach wood pulp and to act as another use of sulfur dioxide, which is very close to B. Yes. Okay, sulfur dioxide kills bacteria, so acts as a food preservative. So I think some time back they used it, in your tomato ketchup sachets, yeah. So yeah, that was what I wanted you to get out from this topic, from this question. Alright, and there is this weird topic called carbonates, which is, they have all about calcium carbonates and the carbon cycle. So what do you think is the answer for this? And yeah, if the year 11s you are here, you will know that I did not teach this topic because there's really nothing to teach. Yeah, it's really so straightforward. Okay, so can I see the answer to this question, please? Oops, looks like I need to teach this topic. Yeah, so yeah, thank you guys. It's B. Yeah, guys, limestone is calcium carbonate. So when it goes through that device over there, what happens? You get calcium oxide plus carbon dioxide. So it's very clear, right? It's very clear that the answer is B, right? I mean, I think you will get upset if I were to teach you a chapter on this, isn't it? Yeah. So very clear, the answer is a B. Okay, another one. Another one. What do you think? The use of limestone. Textbook question, right? Ian, you chose B, manufacture of iron. Didn't we use calcium carbonate to get calcium oxide to react with the acidic impurities to get slag, right? So yeah, D is the answer. So calcium carbonates, calcium carbonates use is all three. It's donkey, guys. It's D. Ian and Ian. Alright, please, iron, we use calcium carbonate to manufacture iron because calcium carbonate is used to produce calcium oxide, which is basic, and we use it to react with the acidic impurities to form slag. So we use calcium carbonate in the manufacture of iron. Moving on. Alright, we are at the last topic. Now, are you able to, like, okay. Look at how they spell gasoline, guys. Did you realize or not? Is that the correct spelling of gasoline? I just realized it, yeah? So anyway, when we learned this topic, right, we had refinery gas, okay? We had petrol or gasoline. Hello, Alicia. Okay, and we had naphtha, then we had kerosene, then we had diesel, then we had lubricating oil, then we had fuel oil. Sorry, this one is inverted, yeah. Then we've got paraffin wax. I don't think it's in your syllabus. And the last one is bitumen. Alright, so please do not confuse this with this, because another name for kerosene is paraffin, yeah. So I'm just going to cancel this. So you need to know the full order of the fractions. Okay, so the answer is D. Yeah, D. I mean, okay, for example, if you did not know the order, okay, but I'm sure you know that bitumen is the last, right? Immediately you would narrow your answer down to boy and donkey, correct or not? Yeah, then you just make your choice. Okay, so you need to know the fractions and you need to know the order of the fractions. That's important. Alright, what do you think this is? Okay, yes, so yeah, so you know that alkene reacts, okay, so I hope you know that alkene here, okay, it reacts with bromine and it also goes through polymerization. What type of polymerization, guys? Can you please key in what type of polymerization? What type of polymerization? Can you please key in what type of polymerization? Addition, very good. And then it goes through a process called, what is the name of this process actually in the middle here? And then you are going to get alcohol. So what is this process from alkene to alcohol? Do you remember? Hydration, absolutely right. So the answer is D for donkey. Yeah. So yeah. So remember that alkanes do not react with bromine easily. Only alkene can react with bromine at room conditions. If it was alkane, yeah, guys, if it was alkane, what do we need to react with bromine? What do we need to react alkane and bromine together? Can I please see it in the chat, please? What do you need to react alkane and bromine together? Because at room conditions, yeah, UV light and what else? You need UV light and temperature, high temperature. Absolutely. Very good. Moving on. Alright, we are reaching the end. Hang on there. Sunlight, yeah, actually, yeah, any form of light will do, but UV light is the best, yeah. Alright, moving on. ethanoic acid. Now, number 4 is wrong because acids contain well, it's not exactly wrong, is it? Yeah, sorry, it does contain an OH, yeah. Okay, it decolorizes bromine water, that's absolutely wrong. So now you're down to A and C. Alright, yes. So the answer is C, isn't it? Because acid does contain an OH group. Yeah, it's correct. It's correct. Yeah. So yeah, although yeah, but be careful. Yeah, because the functional group, if they say that the functional group, okay, is the OH, then definitely this is wrong. Because for acid, this is the functional group. Yeah. So C would be the answer. Sorry about that confusion. Yeah. Moving on. Alright. Wow. This is like the best fermentation question ever. Let me know what you think. Come on. So remember, there are two ways of producing ethanol. One of it is fermentation, the other is catalytic hydration. This method is more friendly for the environment because it uses renewable source of energy. What is not so helpful is the catalytic hydration because that uses fossil fuel, yeah, ethene. Okay, you got it from petroleum. Alright, now it looks very complicated. Very good for those of you who chose D. Very good. Yeah. So I think what's important is we try to get the first and the last. Okay. Now how do we get the first and the last? Guys, I hope you know that fractional distillation is the last. The last thing you do is you separate. Guys, fractional distillation, guys, in this question, it is used to separate. Yeah, for fractional distillation, it is the last. Okay, but what are we separating? Can I see in the chat? What are you separating when you do fractional distillation in this question? Specific to this question, what are you separating? I'm so happy. All of you are absolutely wonderful. Correct. So we know that 3 is the last. And of course, before you do fractional distillation, you've got to filter. Alright, so these are the purification steps. Did that help us? Not really, right? Because now we have to contend with A, B, and D. Okay? Now let's get the first one. What do you think is the first one? Of course, the first one is obvious, right? Alright, the first one is to crush the sugar cane. Okay, to crush the sugar cane. And then miraculously, after crushing the sugar cane, then you got, so I don't know, I feel that there's a disconnect between 6 and 4. After you crush the sugar cane, you should have some sugar juice, right? But then they want us to dissolve the sugar in water. So that's a bit confusing. Anyway, you're going to crush the sugar cane first. So the answer is either B or D. Yeah, there's only ethanol and water left after you do the Yeah, I mean you get a bit of other things as well, Ian. Yeah, but don't be petty, okay? So it's mainly ethanol and water. Okay? So now you're left with B and D. So you need to make a choice between steps 1 and 2. Do you leave it in a warm place first? Or do you add the yeast first? Of course you add the yeast first, then only you leave it in a warm place, right? You leave it in a warm place so that the enzyme activity can be optimum. Alright, so you add the yeast which will provide the enzymes, and then you leave it in a warm place. Yeah, D. I don't know about you, but this question is very good, amazing. And I think this is our last question. Alright, our last question. So when it comes to multiple choice organic chemistry, there's very little they can do to fool you. Yeah, no, you put the yeast in. If you keep it in a warm place without the yeast, what's the point, right? Right, you need to put the yeast in, then you put it in a warm place. No, Rohan, you put the yeast in, the yeast releases the enzymes, then you put it in a warm place. All right. Wow, everyone is hammering this question. Yes. Well, students will choose either A or D, right? Students will choose either A or D. Yeah, but I hope you can see from the polymer that the chlorine needs to be on the same carbon atom. The chlorine needs to be on the same carbon atom. Yeah, the chlorine needs to be on the same carbon atom as opposed to A. Alright? As opposed to A, the chlorine is on two different atoms. That is why D is the answer. And I hope you remember, guys, that addition, polymerization, there's very little in between the monomers and polymer. They look really alike. They have to look really alike. So you got to choose the monomer that best looks like the polymer, and that's why D is the answer. Well, guys, we have done over 40 questions together. I hope that this session has helped you, and I hope that you have enjoyed it as much as I've enjoyed myself. So we have another, if you feel that this is helpful and you have nothing better to do with your time, please join us again on Monday at 3 p.m. Alright, and I will select key questions that we can discuss, and we can use it as our revision. Alright, to the AISS students, I'm going to give, for the year 12, I'm going to give you the Zoom link now, and we are going to go to our Zoom live meeting for me to answer any more questions that you have. Alright, now as always, thank you for watching, thank you for joining us. Okay, bye bye.